Okay, welcome everybody. Welcome to the NASA Earthdata webinar, Discovering and Differentiating Data with the NSIDC Search. This is your host, Jennifer Brennan. While everybody's logging in, although most of you have already found the two polls in the bottom left and middle of your screen, we'd appreciate if you take a moment to, provide some feedback on those two optional polls. That would be helpful. I do have 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. First, I'd like to begin by going over a few housekeeping items related to this webinar. The first is, to ensure best audio experience, the conference has been placed in silent mode. So if you have any questions or any issues at all, please enter them into the Q&A pod, and you can see that on the lower right-hand corner of your screen. This works like a chat. The webinar itself will be recorded and posted to our NASA Online Adobe Connect event catalog, as well as to our NASA Earthdata YouTube channel. I will provide these URLs to you at the end. All presentation files will also be available for download at the end of the webinar. The webinar itself is 1 hour long. We've allocated 45 minutes to the presentation and live demonstration with another 15 minutes for the question and answer period. After the speaker has finished her presentation, what we'll do next is we'll move to the final set of polling questions, and we'll follow that with the question and answer period. As I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar, and you'll use the Q&A pod. Questions will not be answered using the raising hand function. It has been disabled. What we'll do is we'll take all questions using the Q&A pod at the end. One final note, depending upon the volume of questions that we receive, I will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who wish to stay on the line. So let's move next to the agenda. During the first few minutes, our speaker will provide you with an introduction to the NASA National Snow and Ice Data Center Distributed Active Archive Center, or NSIDC DAAC, and also introduce the NSIDC Data Search tool. The next 20 minutes or so will be spent discussing the NSIDC Search project motivation and also the strategies. And then finally what we'll do is we'll finish up with a live demonstration of the NSIDC Data Search tool. It is my pleasure to introduce our speaker, NSIDC DAAC. Amanda?
Thank you, Jennifer. Welcome, everyone. So I will be demoing the NSIDC Search tool, and it looks like many of you haven't seen it before, so this, I think, will be a great opportunity to expose you to it. But before I do that, I wanted to give you a little background on NSIDC DAAC, our data holdings, and the search project that we participated in over the last couple of years to develop this tool. So the National Snow and Ice Data Center is at the University of Colorado in Boulder, Colorado, and our mission is to advance the knowledge of the Earth's frozen regions. So this includes snow, sea ice, glaciers, ice sheets, frozen ground, and other cryospheric climate indicators. We are part of CERES, the Cooperative Institute of Research and Environmental Science, which is at the University of Colorado. And we're funded through and provide data management and service development by NASA, the National Science Foundation, and NOAA. The NASA DAAC at NSIDC is the primary source of NASA funding that we receive. So NSIDC DAAC is one of NASA's 12 discipline-oriented data centers which are around the country. Our focus happens to be on snow and ice. So we're managing data from NASA's past and current Earth-observing satellites, other satellites, and the airborne and field measurement programs. So our entire public NSIDC DAAC holding consists of about 450 data sets. This results in a volume of about 135.6 terabytes. And on average last year in 2014, we were distributing 1.1 terabytes of data per month to users. And all of this data are free and open to the public. So here's a summary of some of the data products that we do have within the DAAC holdings. There are several major missions that we manage data for. AMSRE, Aquarius, ISAT, MODIS, NIMBUS, SMI, and SMAP are all satellite-based measurements. And then IceBridge is an airborne campaign doing laser altimetry. The data holdings span back to 1966 with the visible and infrared imagery from NIMBUS, and they reach into the present with many of the passive microwave and altimetry products that we have. Many of them have global coverage, but some are more polar focused. IceBridge focuses in on Alaska, Antarctica, and Greenland. And they cover the broad range of cryospheric parameters that I mentioned earlier, such as sea ice and snow. But they go beyond with measurements such as brightness, temperature, soil moisture, freeze-thaw state. Some other elements of the hydrosphere are measured with some of these missions as well. So it's a broad range of data products, but it all centers around a common theme of snow and ice. So as a DAAC, one of our primary functions is to make this data discoverable to the users. So NSIDC DAAC has had a data search for many years. In 2000, the NSIDC data catalog or search looked like this page you see here. It was a listing of data products, and user could sort by subject or title. There weren't as many holdings at that time, so this method worked fine. The user could scan through this list fairly efficiently and find the products that they were interested in. Around 2002, what could be considered a true search was introduced when a text field search box was put on our website. This allowed the user to search on keywords, which were then mapped against the metadata for our dataset holdings, and find, hopefully, more customized lists of the data that we might have of their interest. In 2004, search was really enhanced to include what we often refer to as the holy trinity of search, which is keyword, spatial, and temporal searching. So here a user could apply keywords, select a lat-long area, and provide start and end dates to more finely constrain their search and narrow in on the data products that would work for them. And then in 2006, search remained fairly consistent with that model. We still had keywords, temporal, spatial, but we began providing lists of data sets categorized in different ways. This was largely due to search not helping users always find the data sets that they were interested in. So by categorizing around parameters like snow and land ice, or around missions like AMSRE, we were attempting to help users find data of interest through another mechanism than search. So this was the state of search for several years, but we recognized a challenge, and we heard from our user communities that when you're domain focused, you are able to provide a lot of expertise and knowledge about that domain, but many of your data sets end up looking very similar. So with our focus on snow and ice, users have a difficult time comparing data sets in our holdings. With our old search, we did an experiment to see how many data sets would surface if you typed in common search terms. So for ice, you would get back 54% of the 450 plus data sets in the DAAC catalog. For snow, you would return 26%, and sea ice 23%. So this clearly highlighted that a keyword search alone does not really help the users discover data sets in a meaningful way. So in 2013, we decided to take on the NSIDC Data Search Project. We broke it into two phases. Phase 1 ran from March 2013 until November of 2013. And this phase really focused on the back-end services needed to provide a robust search. We overhauled our metadata architecture. We developed some web services in support of search. And the end result was a search that looked pretty similar to what we had, but did provide better results. Phase 2 started in February of 2014 and ran until July. And this phase really focused on the user interface and providing additional functionality that would assist the users in the discovery process. So the overarching goal of both of these phases was to develop a data search tool that addressed not only the challenge of discovering data at a DAAC, but also differentiating them. As we went about achieving this goal, we asked ourselves a few questions. How do users explore data sets? What data attributes are of primary importance when selecting a data set? There's many metadata and documentation elements attached to a particular data set. So we wanted to know which of these attributes really help a user identify and select a data set of interest. And when presented with a list of similar data sets, how does the user choose one over another? What are those qualities that let one data set rise above the others for selection? We developed a search strategy that focused on relieving choice overload without reducing the choices that we were providing our users. So we realized that we have a broad range of users with varying technical and science backgrounds that all have their own broad sets of needs when it comes to finding and using data. We didn't want to eliminate options for a segment of that community only to serve one other population. So we tried to keep the tool general enough that many could find it useful, but also allowed the individual needs to be met. And the strategy also attempted to help users identify which data set really has the best fit for their intended use. And we came up with 3 approaches for doing this: relevance ranking, faceted filtering, and comparable results. So I'll go through in a little more detail what those 3 options mean. So relevance ranking is using an algorithm to find the best match relevant to the metadata content. We used the particular technology of Lucene and Solar, which comes with relevance algorithms. Those would search our metadata and identify matches in different sections of the metadata record, depending on how we had it configured. But out of the box, this didn't quite meet the needs of what we know our users were expecting for data set results. So we leveraged our user services group, who work closely with our users in finding and using data sets, to really build in some firsthand knowledge of our community. We used weightings and rankings to customize the algorithms to really surface those data sets that we think our users are most trying to find and will be most valuable. This was a really flexible way to build in the domain knowledge that we've gained through working with our communities. And then finally, our domain has certain terms that don't necessarily match well in a keyword search. So we had to build in some special rules to these algorithms to make sure we weren't eliminating important results. So for example, the SSMI sensor has a slash in its short name, but oftentimes that is omitted. And we didn't want that to prevent someone from finding the data. IceBridge is often written as 1 word or 2. We wanted both to return the IceBridge data sets. Same with snow depth. Regardless of how someone entered it, we wanted to make sure that it returned the right results. The image in the bottom right represents the frequency with which different terms are searched in our NSIDC search. So for in a given month, this shows that snow and ice were the most commonly searched for terms in our application. So we use that type of information to also help drive how we weighted and prioritized the relevance rankings. So faceted filtering is something that's very common on retail websites. It allows the user to drill into data characteristics to refine their search results. in order to do this, you need to have complete and consistent data set metadata. So in implementing this functionality was an iterative process for us. We would work with our user services group to help us identify which data characteristics would most lend themselves to facets and be most useful to our users. We would then turn that facet on through Solar, and this often would expose inaccuracies or incomplete metadata. So we would take time to improve the metadata, make it as accurate and complete as possible, and then we would put it out for usability testing. Part of this testing involved deciding if presenting all of the metadata elements was overwhelming and if we needed to custom group them. So in the top right is a snapshot of the faceted filtering that you'll be seeing in the live demo. It shows some examples of the custom groupings we did. So rather than present each individual temporal duration of the data sets, we grouped them in less than 1 year, 1+ years, different temporal groupings based on what we think users would need to know, and confirmed by doing user testing. We also found that some metadata elements, like format, had quite a number of values spread across our different data sets. So we discovered through usability testing that rather than trying to group those down too small, it was better to put in a text-based filter to let someone narrow that list of results and more easily find the format that they were interested in. So finally, comparable results. Our previous search would have a results page, but it wasn't something that a user could easily review and make a selection based on differences they were seeing in the data sets. So we went about trying to achieve comparable results by presenting very targeted metadata in an easy-to-scan format. So in the bottom left is a screenshot of our current search results page that you'll see later. And we tried to keep it very minimal on text and graphically represent things such as the spatial coverage of the data set. We also discovered that sorting is a very powerful way to help someone compare results. We implemented sorting for a few different strategies. One is the relevance, the best match based on the algorithm. The other is the extent of the spatial area, when the data set was last updated, and the temporal duration. In order to achieve the goal of providing a very useful tool, we utilized an iterative software design approach. The fundamentals of this are to release small blocks of functionality, obtain feedback, and then assess the next highest priority feature. This allowed us to continually evaluate what we were doing and providing, get direct feedback from users, and adjust the direction where we were heading. So it may mean that in the beginning of the project, we were thinking of including a certain functionality, and then later after testing, we realized there's something else we can do that would be better. So this iterative approach really helped us keep aligned with the end goal. We also performed extensive usability testing to ensure that the design and the functionality aligned well with our users. We had individuals in-house who were trained in usability testing and met with new NSIDC employees, NSIDC grad students, and even our user working advisory group to sit down with them and go through specific use cases and test the interface at various stages of the project. We would get feedback from that and directly incorporate it into the future development. It was an incredibly valuable process to go through. So Search was released in summer of 2014, around August, and that's when we really started advertising it. So based on the metrics, we definitely saw an increase of usage of NSIDC Search. But the even more promising information is that The spike didn't occur just right after we started advertising it. You can see that usage climbed and has remained much higher than with our past search tool. We're taking this hopefully as an indication that people are coming back and finding search to be useful for finding data. And we're seeing even a greater spike of usage in the last month. So at this point, I want to take us over to the search application so that I can demonstrate some of the functionality. In addition to redesigning our search tool, we realized that it would only be useful if people could find it on our website. And we had heard feedback from users that the navigation of our website could be challenging as there was a lot of content. So in addition to releasing search, we also released some changes to our website structure. There are a few different places from this NSIDC homepage where you can access the data search. From our top navigation, we have a data link, and it drops down an NSIDC data search text field. If you enter a keyword in here, you're directly taken into data search. At the top of the navigation panel, we also had a site-wide web search. We changed that so that you could also search across data sets. So if you select data sets in the drop-down, enter a term, you're again taken into the search application. And finally, on the left nav, there's a data search options section, and the first link there takes you to NSIDC data search. So we tried to make it quite prominent on our site. And we also cut down on the other means of discovering data, such as those static lists that I mentioned earlier. Thinking being that search now gets users much more value than it did in the past, and those other forms of discovering data sets are no longer useful and would only provide confusion. So as we were developing search, we had certain use cases and user personas that we used to run through examples and see how it was performing. So I'm going to take you through a few different examples of what a user might do when they come to NSIDC Search. There have been a few major cryospheric events of late. One is the Arctic sea ice maximum, which was reached in February, being the all-time lowest in the satellite record. So if someone was interested in learning more about the sea ice extent, not particularly a sea ice expert user, but someone who's maybe writing an article or just interested in knowing more and seeing some data, they may come to the NSIDC search tool and enter sea ice. They know they're interested in the Arctic, so they can apply a spatial area. And we do have a global view and a south polar view. So if they switch to the north polar view, they can select a box around the Arctic and apply that to their search. And they may not particularly care what the time period is, if they're more interested in trends. So they might search from this point. So from the results numbers, you can see that this search returns the user 116 data sets. That's a pretty for them to sort through and compare and try to determine which is best for their needs. By scanning the metadata that's provided, they might notice that there's a lot more than just ice extent being listed in the parameter fields. So if they are interested in extent, they can come over to the left to the facets and utilize the parameter facet. The ordering of the facets on the left was carefully considered based on the value and usage that our user services group felt the users would need. So parameter is a key aspect of a data set. Therefore, that's the first one listed. So if the user types extent, it'll reduce that list to just those that have extent, and they can see that there is an ICE extent parameter, and the number on the right indicates to them how many data sets include that parameter. So by selecting that, they've instantly reduced their list down to 23 data sets. That's still a fair number. If they are interested in more of a long time trend, they might want something that extends back as far as possible. So they could then use the temporal duration facet and select 10 plus years to find products that are going to give them more of a trend climatology-based measurement. Now being down to 21, the user might consider what format of product that they can most easily work with. Many of our users aren't as familiar with formats like NetCDF or HDF, and imagery files such as PNGs or GeoTIFFs are something that they're more comfortable with. So if this user was familiar with GeoTIFF, they could select that and be reduced down to 6 data sets. So again, knowing that they're mostly interested in a trend, they then might decide to sort to see which has the longest temporal duration. So if they select duration longest to shortest, we'll now see that this MODIS sea ice extent product goes back to 2000 and has data to the present and includes ice extent. If they were interested in reading the summary, they can click more details and find out a bit more about that product. So if they decide that this is something that they want, on the right side, we have a large Get Data button. Many of our data sets have different methods through which a user can access them. So this button is going to show the user the different options available to them. Some of these are terms that people might be familiar with, like FTP, but others are tools or services that they may not recognize. So there's an information icon that expands the box out and gives them a little bit more detail about what that service provides. In the case of this data set, it happens to be available in the NASA Search and Order tool Reverb, which would then allow the user to subset and reproject and reformat the data. If they select this link, it does take them over to the Reverb application, but it pre-populates the data set that they were looking for to give them a head start in obtaining the data through Reverb. So I'll now reset search and we'll go through another example. This time it's maybe a more scientific experienced user who knows particularly what sensor they want data from. So if they're interested in ice velocity data in the Antarctic based on radar, they might start by typing ice velocity. Another feature we included is the auto-suggest dropdown. So when I started typing, it's matching my words to elements in our metadata or other keywords that people have searched on. So I can see there's Antarctic ice velocity data. I can select that. I'm maybe not worried about entering a spatial area because I've already specified Antarctica. So I'll just search from here. So in this search, I only get back 16 data sets, which is much more manageable, but I know that I'm particularly interested in radar data. So another facet that we provided is the sensor facet. Again, it was a long list of values, so we included the filter box at the top. So if I type radar, I can see it provides a list of different types of radar. So even though we're presenting only the short name, if you hover over that short name, the black box appears and gives you the full name of that instrument, and the text filter is searching against those. So in this case, if I were interested in SAR, I've had it returned to my list, and I can select it. So I'm now returned 2 different measures, NASA measures SAR data sets. At this point, I might decide that what I want is the most recently updated data set. So if I select last updated, newest to oldest, this is going to give me the data set that was most recently updated, not necessarily in terms of the time series, but in terms of maybe changes, updates to the data file, or updates to the metadata. And again, if I want more information, maybe it's not provided in this results page, I can click on the dataset title, and that will take me to the dataset landing page. So this is the authoritative page for that dataset that provides all the information about it. It has a link to full, complete user documentation. It has links to the various data access methods. It includes the data citations that should be used to cite the data. It notes the authors, the parameters, and the instruments, and also has a full metadata record output. So the user could come here, learn more about the data set, access the data directly from here, or if they're still in data search, they can go back and use the Get Data button. So in this case, this data set is only provided by FTP. If they select FTP, they're taken to a user registration form. This is currently an optional registration form. If it's completed, then we can keep you appraised of data set updates. But it is possible to bypass it and go directly to the data. So we're now on the FTP site, and we can see directories for the data sets. So I will clear search, and we'll go through one more example. The western U.S. has been in the news for its lack of snow cover. So if someone were interested in what the state of the snow cover is in California or the western U.S., they might come and enter snow cover. They might decide to select that area on the map. You can draw a box. You can also zoom in if you want to be more precise. And then we can apply that. And in this case, maybe they're interested in just this past winter. So we can use the temporal calendar date picker and specify winter months that we're interested in, and then perform our search. So I get back 22 results. It might be that I'm interested in really what NASA has in terms of snow cover data. So another facet is the program that funded the generation of the data product. So one option is the NASA DAAC, and then we also do have NOAA data. But if I were interested in NASA, I could select the NASA facet, and that's going to reduce it down to just those NASA data products. I then might decide I am most interested in this top data set, the SNODAS data product. So I can again look at the data access options. It has FTP, it has a search and order tool, and I could choose which one I might want to access the data with. If someone were not interested in a regional area, but decide they're actually interested in global snow cover, we also provide a spatial coverage facet that will reduce the list down to just show global data sets. This was a facet that we did a lot of usability testing on. There's different ways you can represent spatial coverage. Some ideas were having options like regional or the different hemispheres. But ultimately, at least with our user community, we found that someone was either interested in a more regional study, in which case would likely enter spatial coordinates, or they wanted a product that had global coverage. So by including the show global only, it reduces the list down to just those that have full global coverage. So if you're on NSIDC Search, and you have questions about the interface, questions about the data sets, or even have suggestions about what in NSIDC Search might assist you, there is this Ask Us button to the right. If you select that, you'll have a form. You can fill it out, and this will go directly to our User Services Office, and they can help you with whatever question or suggestion you might have. So that concludes the live demo. I have a little bit more presentation I wanted to share with you. So I wanted to leave you with a few NSIDC DAAC resources. We do have a DAAC website. The URL is provided there. This site gives an overview of all the different DAAC data sets that we currently manage. It includes a table similar to the one I provided earlier so that you can. It also has a page which describes all of the various data access options. Some data access options were developed at the DAAC, but there are also utilities like Reverb that were developed by NASA for use across all of the DAACs. So these are very useful if you're looking for data spread across the different data centers. So I provided a link directly to that because it's often a useful table to look at and decide which means is the best way for you to get data. Finally, there's a link to NSIDC Search, but hopefully you'll be able to find it on our website and won't need that. And then we are very interested in any feedback that you have, whether you're a data user or a data center developing an application similar to our search. Please feel free to contact us at nsidc@nsidc.org. If you discover that there's any behaviors of search that you're not sure what to make of or have suggestions, we'd really love to hear them. I mean, this hasn't been out quite a year yet, and we do plan to continue to build upon it and add new features. So with that, I'll turn it back to Jennifer.
Okay, thank you, Amanda, and thank you, everybody. What we're going to do next is we're going to move along to the final set of polling questions. You can see them here. I'll give these about 5 minutes or so people have an opportunity to type in their responses if you're interested in answering. And then from there, we'll move along to the question and answer period. So be sure to stay in the room and or stay on the line to participate in the question and answer period. All right, so thanks. Let's give these a few minutes, and then we'll pick up with the question and answer period momentarily. Thanks, everybody. Okay, everybody, I'm going to give it just another minute or so, unless I see a spike in activity, and then we'll move on to the question and answer period. Okay, everybody, we're going to go ahead and move along to the question and answer period, but certainly if you have any additional feedback that you'd like to provide, feel free to email me, and it's jennifer.l.brennan@nasa.gov, and I will forward that information along to our speaker, Amanda, to address offline, or certainly type it into the Q&A pod. Before we move to that, I did see a question in one of the polling question responses that I thought would be good to actually address now, and then we'll switch over to the full Q&A pod with the questions. And that is, one of the participants asked, if I look for MODIS imagery of icebergs, will the search tool search all of the DAACs? Amanda?
Currently, it's only searching Reverb or the new Earthdata Search client, which were developed by the EOSDIS project. Those do search across all the DAACs, and having the NSIDC Search tool search against other DAACs is something that we've considered for a future release. So it's a good question, and it'll be noted as we consider whether that's valuable or not.
Okay, thank you, Amanda. And then our first question to address within the Q&A is it possible to access level 0 data with instrument parameters for developing your own algorithms?
Currently, the missions that we support do not have us distribute level 0 data. NSIDC DAAC does archive it for preservation and archival purposes, but it's only level 1 and higher products that the missions enable us to distribute.
Okay, thank you, Amanda. Are there additional questions? At this time, I am scanning our Q&A. We'll give it a minute, give people, okay, here we go. Maggie, are your metadata schemas available?
We could, I'm not sure if they're publicly available. We are using an OpenSearch web service to do the querying of our metadata holdings, and that is a public API. In terms of a basic schema model, I don't believe we have that out on our public site, but I could take an action and we could see if that is there, or could provide it to you if you were really interested.
Okay, thanks, Amanda. And just while people are thinking about potential questions, a couple of points. The presentation file, if you look in the lower right-hand corner of your screen, is available for download here, as well as the agenda. If you select either one of those files, you will be prompted with an opportunity to download the file. So that's one point. And then you see over here on the left, and this addressed some of the comments made earlier, The webinar file will be posted within a couple of days. It will be posted to our NASA Earthdata YouTube channel, as well as to the online Adobe Connect catalog, which is the tinyurl.com Earthdata webinar link below. So you can find some information there. And generally what I'll do is I'll send out a message to all of the participants and let you know that it's been posted. And then I do have another question here. And again, getting back to the comment regarding the metadata schemas, and this user has followed up with a comment saying that would be very interesting for us. And let's see here. Here comes your next question. Does the space coverage specified in the query match data sets which contain it, or just overlap is sufficient for matching?
It actually does both. If any portion of the data set spatial coverage is intersected by the spatial search, so whether the search boundary fully contains the data set or just overlaps a portion of it, it'll return in the search results. The strategy for using that approach was it's better to provide more results than less, so we didn't want to eliminate a data set that maybe wasn't fully contained within the spatial search area, only had a portion covered. So it's covering both situations.
Okay, thank you, Amanda. Any additional questions? Anybody? Our next, for those of you who may be interested, if you went to the tinyurl.com Earthdata webinar, I do have a webinar announcement listserv, and our next webinar, which will be held on April 29th, will feature, our speakers will be from the NASA Atmospheric Science Data Center DAAC, and will focus on geospatial tools and web services for accessing some of their tropospheric data and their atmospheric chemistry data products. So you might sign up and you'll receive an announcement for that upcoming webinar. Okay, here is another. Okay, thanks for the seminar. It's always good to know about the process involved in the developing of these services. Thank you for the comment, Mateus. Any further questions?
Jennifer, I did try to post the API for OpenSearch. I don't know if that's
I do see that. So Amanda has
everyone.
posted the link to the OpenSearch API, and you should all be able to see that. It's nsidc.org/API/OpenSearch. Let's see. Can everybody see that all right? It looks like so. All right, any further questions from anybody? All right. I don't see the API URL. Okay, so Dr. Martin, hold on a second. I will type it in again. Let's see. And tell me again the URL, Amanda, if you would. The
NSIDC.org/API/OpenSearch.
All right. Okay, you've got it. Okay, great. Well, now it's been sent twice. All right. If there are no further questions, I mean, I'll give it a few more seconds here, then we will go ahead and end this webinar. And I do want to thank all of you for participating in the webinar. I hope to be able to see you in an upcoming webinar. We've got several planned, along with a follow-up if any of you participated in our Giovanni webinar. It's almost been 2 years ago now. It's hard to believe, but we will have the next version of Giovanni, Giovanni 4, and discussion of the federated Giovanni tool in early May. So be looking for that on the website as well. And Amanda, thank you very much. Thanks, everybody. Let me make sure there's nothing further. I don't see anything further, and so in the next couple minutes, what I'll do is I'll leave the virtual meeting room open for those of you who are interested in downloading Amanda's files. I will log off the telecon here, and certainly if you have any questions or anything further, feel free to email me, and I will forward that information along to Amanda. And I do thank all of you very much. I hope to see you next time. All right, thanks everybody. Bye-bye now. We're going to log off the telecon at this point, and I will leave the meeting room open. All right, thank you.